Today, we're diving into something big, a new way of thinking about trust in technology. We're going to talk about a new architecture that's trying to solve a massive challenge. How do we safely plug this next wave of super powerful AI into the one tool we all use every single day, our email? And let's just start with the scale of what we're talking about here. This quote, it really sets the stage. This isn't just a nice thought. It points to what an AI-powered workforce could actually do. We're not talking about a tiny little productivity bump here. We are talking about a potential 10 times increase in our collective human ability to get stuff done. But, and this is a huge but, here's the problem. To unlock all that amazing potential, this new AI workforce, well, it needs a way to communicate and work. And for pretty much every business on the planet, that way is email. And right away, you've got this huge clash between this incredible opportunity and some really significant risks. To really get this, we first need to understand the new kind of AI that's on the scene. This is all about what's called agentic AI, and this is where that opportunity and that obstacle really collide. So, what is agentic AI? Well, you gotta think way beyond a simple chatbot. These are systems that can act on their own. They use those big language models as a kind of brain to figure things out and tackle complex, multi-step jobs. So, for example, instead of you asking it to just draft an email, an agent could research a whole topic, summarize its findings, then draft the email and even schedule a follow-up meeting, all by itself. The entire point is to let the agent do the heavy lifting for you. Okay, but the second you give these powerful agents access to your email, you are creating a brand new and very, very dangerous vulnerability. It's like an unseen back door that attackers are already starting to figure out how to kick open. And this threat, it has a name. Email Agent Hijacking, or EAH. And the concept behind it is actually terrifyingly simple. An attacker sends a specially crafted email, not to you, but directly to your AI agent. That email has hidden instructions that basically rewrite the agent's original mission. And just like that, the attacker gets complete remote control. And the scariest part, you would never even know it happened. So just how effective is this kind of attack? Well, a recent, very detailed security study tested over 1,400 real-world email agents. You want to know their success rate for hijacking them? 100%. Let that sink in for a second. Every single one was vulnerable. This is not some theoretical risk anymore. It's a fundamental, critical flaw in how we're building these systems right now. And once an agent is hijacked, the attack itself is it's shockingly simple. The attacker doesn't need to write complex code. All they need are 4 basic commands to create total chaos. First, they tell it to search your entire email history for words like password or invoice. Second, they retrieve any sensitive data they find. Third, they draft a new malicious email, maybe a phishing attack on your CFO. And finally, they use the send command, and that email goes out from your account looking completely legitimate. It's a devastatingly effective 4-step hit. Okay, this is a massive problem, a huge one, but it is not unsolvable. The solution, though, requires us to completely change how we think about the architecture. It requires something called the Safe Broker Principle. SAFE stands for Stay Away from Email Servers. And the core idea here is actually pretty brilliant and kind of counterintuitive. Instead of building these complex modern API connections that are really hard to lock down, you intentionally separate the AI from the email server. The solution uses the oldest, most reliable part of email, the SMTP protocol, to act as a neutral middleman between the AI agents and the people they're working with. It's literally using old tech to solve a very new problem. And here, you can really see the two approaches right next to each other. On the left, that's the current risky way of doing things, a direct API link. The AI is basically chained directly to the mail server, and that's where the vulnerability is. But the safe model on the right completely decouples them. The AI and the human, they still talk through the email server, but neither one has direct privileged access to the other's home turf. The server becomes a go-between, not a backdoor. So the key thing to understand is this. The email server itself completely changes its role. It's no longer a weak point. It's now a secure, auditable buffer, like a digital, demilitarized zone where AI and humans can work together safely. And here's the best part. Every single interaction is logged permanently, creating a perfect, unchangeable audit trail. So how does this actually work in the real world? Well, the safe architecture isn't just about keeping systems apart. It's about actively building trust that you can verify using a really clear multi-level protocol. This is the guiding philosophy right here.
Trust and safety aren't just an accident or something you hope for. In a safe environment, control is deliberately built into every single layer of the system, from the ground up. And this is the framework for how you engineer that trust. It's called the multi-level verification, or MLV protocol. Think of it like a series of security checkpoints that every action has to go through. It starts at P0, basic security. Is this sender who they say they are? Then at P1, you have an AI safety check. You can picture this like a supervisory AI watching over the other agents, just to make sure they don't do anything weird or unpredictable. Then comes the most important step, P2, the human in the loop, where a real expert validates and approves the action. And finally, P3 logs everything, creating that permanent record for compliance.
So let's just break that down one more time. You've got zero trust at the edge, nothing gets in unless it's verified. You have automated AI safety checks, kind of like a manager watching over an intern. You get that unchangeable audit trail for regulators. And let's be crystal clear. For any decision that really matters, the most important piece is the mandatory human in the loop. The AI can propose an action, but a human expert must give the final sign-off. The automation is there to serve the human, not the other way around.
So what's the ultimate impact of all this? What does this really mean? By solving this technical problem of trust, the SAFE architecture opens up a whole new strategic vision for how we work, one that's auditable and one that's, well, harmonic. This quote from the source material just nails it. By creating that separate, auditable system right there in the middle, you make something truly new possible. Collaboration between humans and AI that's not only productive, but also crucially safe. And this is what that future starts to look like. It's not about replacing people, it's about creating a safe, controlled environment where AI is amazing at handling the sheer scale of routine work, freeing us humans up to do what we do best, provide that critical judgment, that deep expertise, and that final authority. And the whole thing happens inside a system that's transparent and completely auditable. And this brings us right back to where we started, that vision of a tenfold increase in our capacity that is only possible if you build it on a foundation of trust. The SAFE principle gives us that foundation. It changes email from being a massive liability into a secure launchpad for the future of work. So really, the question isn't if we can do it anymore, it's what we will do when it's possible. When AI and human collaboration is perfectly safe, what will you achieve?